All right, Algebra 2. This is actually fun math. I love it. It's just canceling things out and doing things. Today we're doing simplifying rational expressions. When you know how to do this math, it's kind of fun. This is very GCF heavy, so let me go ahead and put that down. Let me write that down. You don't have to write this down, but it's very GCF heavy. That's greatest common factor. I'm going to be going around today, and I'm going to be finding out who still can't do GCF. If you're still struggling with GCF, I'm going to start pulling y'all in math time repeatedly until you finally get GCF. Everyone in my class has the capacity to learn GCF. And if you haven't yet, your time's up. You're going to learn. So you need GCF to get this done. I'm going to make a separate video on GCF if you don't know how to do GCF, because this you should know by now. And again, if you don't, I'm not criticizing you. We're just going to fix it. With that said, let's go ahead and talk about how to simplify each rational expression. I'm going to make up an example over here, and I do not want you to do anything. I just want you to pay attention. So the first thing I'm going to talk about is simplifying and what we mean. Rationals, y'all. The term rational, it means fractions. Where does rationals come from? It comes from the word ratio. And ratios essentially are always represented as fractions. So that's where it comes from, rationals, ratios. So when you see rationals, you should be thinking fractions. So what does simplifying rational expressions mean? Y'all, it means simplifying fractions. That's all we're doing today is simplifying fractions. But of course, this is algebra, so it's going to have a little bit more complicated things to simplify. So I'm going to give you an example over here of what simplifying just a regular number looks like. 4 divided by 10. I can see those are both even numbers, so I know that 2 goes into both of these evenly. That's a GCF thing. So if I did 2, I would divide 4 by 2, which gives me 2, and I would divide 10 by 2, which gives me 2 over 5. These are the same expressions. They are equivalent. But this is the simplified version. This is the simplified rational expression. See that term right there? Simplified rational expressions. So we're going to basically be using all of our rules on how to simplify. Let's start with number 1. Here's my recommendation for when there's no equations. And what do I mean by that? You see over here where there's minus signs and things like that? Like this is going to end up giving us not equations, sorry, polynomials. Anything like a minus sign, a plus sign, multiple types of x's, etc. Those are polynomials. These are just terms, right? This is just a 4, an x, a y, a 12, an x, and a y. These are the easy ones to simplify. They do get more difficult as we go forward. So with that said, I'm going to go ahead and talk about how to simplify number 1. Number 1 simplifies first. We're going to do this. And I would do this in 2 stages. The first thing we're going to do is simplify our numbers. 4 divided by 12. That can simplify. 4 can go into both of those. So 4 divided by 4 is 1. 12 divided by 4 is 3. At this point in the game, if you don't know what's going on, you need math time. And again, I'm going to find out who can do GCF and who can't today. And I'm done with this battle. I should have fixed this last semester, but I'm going to fix it now. So with that said, the next thing you have to do is remember last unit, our rules. When we have an x and an x, and we have exponents, and they're being divided, because this says x3 over x7, the rule is you subtract. So 3 minus 7. So 3 minus 7 gets you x to the negative 4. X to the negative 4, because 3 minus 7 is negative. So no matter what, on your first go around, just do one rule at a time. Put it in the numerator every time you do the subtraction. Now this next one is y to the 4 over y to the 2. So I'm going to go 4 minus 2, which gives me y2. Now on the next step, what you're going to do, this is step A. On the next step, you're going to clean it up the rest of the way. So I don't need to write that 1. No one cares about the 1 in there, but my 3 stays on the bottom. This negative number needs to come down. I don't like negative expressions, so I'm going to move it down. That's the rule. If you don't know what that is, it was in Unit 7. And then y squared is at the top. So that's it. That's the answer for number 1. Now, this is where it gets cool. So I'm going to go ahead and I'll eventually erase all this. Actually, I'm going to erase this now so y'all can see me do this. Hold on. Clear annotations. Here's where it gets cool. I have gone with y'all every class period. I've done the crazy thing where I'm like, excuse me, what is 5 divided by 5? And y'all will answer 1. And then I'm like, what is 6 divided by 6? Y'all will answer 1. 7 divided by 7, y'all will answer 1. But then I'll say x divided by x. And a lot of y'all will be like, the answer's x. Y'all, anything divided by itself is going to be 1. So x divided by x is 1. The same way 5 divided by 5 is 1. The same way 6 divided by 6 is 1. And I said anything divided by itself equals 1. So what does that mean? Well, check this out. If I had an x plus 2 in a parenthesis on top, and I had an x plus 2 on the bottom, and then let's say, I don't know, I had another little thing right here, x plus 4, who cares? Each of these parentheses basically represents separate terms. They represent separate terms. So what do I mean by that? You can consider x plus 2. Oops, I don't want that up there. Hold on. You can consider x plus 2. Hold on. X plus 2 one term. So x plus 2 divided by x plus 2, it cancels out into 1. That just turns into 1. That's it. So what do I mean by that? So, okay, mister, what if I had this? What if I had x squared plus 3x plus 4, and it was one term like this, but then in the denominator, I had x squared plus 3x plus 4. Does the rule still work? Can I still group this and cross this out? Yeah, you can. Is this term the exact same term? You see it, x squared, 3x, 4, they're the exact same term. Anything divided by itself is 1. So we're going to be exploiting that. Before I continue though, and this is silly, but the rule is the same no matter what. That's supposed to be a star. The rule is the same no matter what we're doing. If I had star divided by star, anything divided by itself, it comes out to 1. You need to understand this concept because we're going to be exploiting this while we're doing this lecture today. So I'm going to go ahead and talk about 2. When you come to these problems right here, these are the easier problems. You have to think GCF. So what I'm going to do on my first step is I'm going to apply any GCF that I can. So I'm going to focus on the numerator first. I see an 8, an x cubed, a 2, and an x squared. Between the 8 and the 2, I can pull out a 2. All right, that's good to know. And then I look at my x cubed and my x squared. And when I look at those, they both have x's. You're going to pull out the smallest x, meaning in this case, x squared. So here we go. I'm going to go ahead and finish this. I'm going to end up with 8 divided by 2 is 4. And then I'm going to have 3 minus 2. See how I'm doing this? I'll have 1x left over. And then I pulled out a 2 here. I pulled out a whole 2x squared. I pulled out a whole 2x squared. So I'm going to have left over x minus 1. I'm going to find out everyone again today who's struggling with this still. This is a skill we have to have mastered at this point. So this one and this one right here is the same thing as the numerator, the very top one here. So now I'm going to go to the bottom, and I'm going to do GCF on the bottom. So on the bottom, I'm going to be able to look at this and be like, well, the numbers don't make any sense. I can't pull anything out, but I can pull out an x. Remember, there's no exponent. That's an x to the 1. So I'm going to pull out an x to the 1, and that leaves me with the 4. 2 minus 1 is an x, and then there's no x over here because I pulled it out, so that leaves me with a 1. Now, here's the cool part. Check it out. This says 2x squared times all this crap, x times all this crap. Whenever you have multiplication, you can do some crossouts. It's a little different when you have like polynomials and things, and we'll talk about that later. But like this is just multiplication straight across. This term, 4x minus 1 and 4x minus 1, they can divide out and cancel out to 1. And now you are left simply with this thing right here. But you're not quite done. You have an x to the 1 on the bottom. So what's the rule? I'm going to bring down my 2 here. And now this is an x and this is an x. This is a division bar. So the rule is 2 minus 1, which comes out to positive 1. And then there's no negative exponents. Everything looks good. This is our answer for this. So 2 starts off as this and then clears itself out and reduces all the way down to this point, which is kind of cool. I'm going to do one more little example on this main lecture, and then I'm going to move into separate videos for all the rest of the notes. So here we go for number 3. X minus 5 can't simplify at all. I'm going to have it as a group right now, though. On this next one, I can pull out a 4x. I can pull out a 4x, which gives me x minus 5. That's pretty epic. Now I see this 4x times all this stuff, and I have an x minus 5 up here. I'm going to cross these out, and I'm going to end up with, oh no, mister, there's nothing on top. What goes there? In this case, if you cross everything out, and there's nothing in quotations on top, you put a 1 there. You put a 1 there. And then what's left over? 4 over x. Y'all, this is it. Simplified, done, and done. So I'm going to go ahead and break the examples into other videos so you can just get the quick, what's it called, answers on it.